So in section 3.4, we are going to talk about marginal cost. Okay, so the word marginal, the way you can remember it is it starts with an M, and that's the letter that we use to look at slope. So if I'm just talking about cost, or if I'm just talking about revenue, or if I'm just talking about whatever, then when I go more specific and I say the marginal cost, what I'm actually looking for is my first derivative. Okay, and I want to know what you're finding is how that cost is changing at that precise moment in time, or whenever X number of things are being produced. So it's going to be easier if we give you an example. So we've got the cost of producing X number of items is 2,000 plus 2x minus Atlantic Ocean. That's a lot of zeros. All right, so I get 0.0001. 0001 x squared. Okay, so again, what happens if we produce 0 items? We still got to pay $2,000 in costs. Okay, what happens if we go to 6,000 items? Hang on, I gotta sneeze. Hey God. God bless me. All right. So I'm looking for the actual cost of production. Okay, and I'm given an interval of 0 is less than or equal to X, or is less than or equal to 6,000. All that means is I can't produce any negative numbers, because I can't produce a negative number of toothbrushes. I can't produce a negative number of toys. Okay, so it's got to start with 0. And then we're going to max out at 6,000, and that just depends on your business model. So, I'm so sorry, I'm fighting a cold. All right, so I want to know, in this particular case, what is the cost of producing 971 discs, okay? So I am going to simply substitute this in. So I've got 2,000 plus 2 times 971 minus 1/10,000th of 971 squared. 971 squared. Okay, so when I slap that in my calculator, which would be right here, what I am going to get is, now, I don't know if you know this. I don't know if you have a graphing calculator. I think you're supposed to. All right, so if you have this lovely little thing right here, shove this in your y equals. We've done this before. 1, 2, 3. And then I say plus 2x, and then minus 1, 2, 3, 1x squared. Okay, so all I've done is enter this thing into my y equals. Can you see it? There it is. Okay. Now, if I go to the table, I can set the independent to ask. So I just did second window, and that took me to table set. And I go over to where the independent variable says ask, hit enter. Okay. And now I can go second graph, which takes me to the table. And it's going to say, okay, fine, what X values do you want to do? So this is going to be, we did this with limits, but this is going to be a time saver. So instead of entering the same thing over and over and over again, now I just got to say, okay, tell me about 971 and tell me about 1811. So when I do those, for 971, I get $3,847.70. So $3,847.70. When I produce 1,811, okay, so 1811, it's actually going to cost me $5,294. Okay, so that's algebra. That's basic stuff. Now I want to find out the marginal cost. In other words, if I produce a specific amount of items, what will my cost per item be? What will my cost per item? Okay, so I'm just finding out the cost of 971 items. I'm finding out the cost of 1,811 items. Marginal cost will tell you the cost per item. So first thing I'm going to do is take a derivative. Okay, goodness, I'm so sorry, y'all. All right, so the derivative of 2,000 is 0. The derivative of 2x is 2. And the derivative of 1/10,000th x squared is going to be negative, and then 2, because you drop the 2 and multiply, and then x to the first. So that's your formula for marginal cost. Well, now, how much is it per item to produce 971 items? So again, I can go here, and I'm going to go in my y sub 2, okay? And that's just going to allow me to do it at the same time. So 2 minus 0.1232x. And now when I hit table, it should just go ahead and populate. So at 971, I get an answer of 1.8058. So 1.8058. That means it's almost $2 per item. Okay. If I evaluate it at 1811, I get 1.6378, which means it's cheaper per item. It is cheaper per item to produce this. You can't see. All right, because it's only $1.63. Now, these are positive values, okay, which means the cost is still going up. The cost is still going up. It's just not going up rapidly. All right, so that means you could do number 2. All right, so number 3 says, okay, I've got C of x, and this is going to be producing a desk, or desks, okay, plus $250,000, okay? That is my cost function. So the first thing I want to do is I want to find the average cost. Sorry. All right. So how do I find average costs? Remember, bar C means you divide everything by x. So 100x plus 250,000, divide all that by x. And now I'm going to clean it up. So bar C, or the average cost of x, 100x over x is 100. Good grief. And then I get 250,000 over x. But remember, if it's over x, I can bring that x up top with a negative exponent. Okay? So all I did was take this that has an exponent of positive 1, and I took it from the denominator up to the numerator, and I made it an x to the negative 1. So now I can find the marginal average cost function, because I'm going to take a derivative. So the derivative of 100 is 0. The derivative of 250,000 x to the negative 1 is going to be negative 250,000 x to the negative 2. And remember, you could rewrite that as negative 250,000 and then over x squared. Okay? So what happens to the limit of this thing as x gets very, very, very large? Okay, so if I want to take the limit as x goes to infinity, effectively is what you're doing. Okay, I want to know the limit of this thing. Okay, so if I shove in numbers, these are going to get bigger and bigger and bigger and bigger, but this is going to stay the same. So what does that look like? That looks like a negative number. Oh, goodness, I'm sorry. All right, a negative number over an astronomically huge number, which the further out you get, remember, if you've got a smaller over a bigger and this keeps growing, that's going to go to 0. Okay? So the more you make, the average cost per item goes to 0. Oh my goodness. All right. So now we know how to do that one. All right. So that means you can do that one. Hang on. I think you can do the rest of these. Okay, so the rest of these in this section are pretty straightforward because you're just finding a price and that type of thing. We already went over the formulas in the last section, so you're just doing basic derivatives. Okay, so that being said, actually I'm going to do number 10 with you. All right, so number 10 is we have a new notation. So I have the cost function in terms of x is 0.892 x to the 1.1 power plus 1841. And my instructions are find, so this isn't cost, they're going to call this the consume function. Okay, find the marginal propensity to consume. So what we're asking for is, oh goodness, dc over dx. Okay, dc over dx. So what that means is this: I can take the derivative of both sides. So what's the derivative of c? It is 1, and then I can say, well, I took the derivative of c. Okay, so this is a new notation. And then I can say, all right, what's the derivative of the rest of this thing? So I'm going to drop my 1.1 out front. So I lost my calculator. So 0.892, hang on, 0.892 times 1.1 gives me 9812. So I get 9812 x to the 1.1 minus 1 is 0.1, and then that goes to 0. Well, here's the deal. You took the derivative of x. So this is another notation that I referred to before. I took the derivative of c, which was 1. I took the derivative of x, which was this. And now I can divide both sides by dx. So what you found was dc dx is 0.9812 x to the 0.1 power. What that means is you've still taken a derivative. Okay, the process didn't change at all. But now what I'm telling you is what was my original function, which was c. What was the variables I was playing with? They were x's. Okay, so that's what you're finding. That's what this means. The process of differentiation is the same. This is just a new notation. Okay, so it still means c prime of x. Okay, and that being said, I'm going to go take cold medicine.